everyone. Welcome to AKN Sprint Education. Myself Naveed, and today let us discuss about tangents and secants to a circle. So our top discussion is about what do you mean by tangent and what do you mean by secant to a circle. Students, what do you mean by circle? So according to mathematical terminology, this board you consider as a plane. See, these are the collection of points in a plane which are at fixed distance from the fixed point. This is our fixed point. See, collection of points in a plane which all are at fixed distance from the fixed point, and that fixed point is called center of the circle, and that fixed distance is called radius of the circle. This fixed point is called center of the circle, and that fixed distance is called as radius of the circle. Got it, children? What do you mean by circle? Circle is nothing but a collection of points in a plane which all are fixed distance from the fixed point. When we join these all collection of points, you will get a circle. So, what is the definition of circle? Circle is nothing but a collection of points in a plane which all are at fixed distance from the fixed point. And that fixed point is called center of the circle, and that fixed distance is called radius of the circle. It is represented by R. Right? Now, so this is a, coming to this, what do you mean by line? This is the line L, which is represented by the small letter either L, M, N, etc. Okay? Which can be, a line can be extended endlessly on both the direction. Okay? So actually, there are three possibilities for a given line and to a circle. See children, the three possibilities, this is a circle and this is a line, circle with center O, and this is line L. This is the first possibility. Coming to second possibility, this is a line, circle with center O, and this is the line L, and this is the circle, and this is the line, this is the circle with center O. These are the three possibilities. Possibility number 1, 2 and 3. If you observe case 1, circle and the line, they are not intersecting at any point. Okay? Now coming to second case, line L which is intersecting the circle at 2 points. For example, this is point A and this is point B. A line which intersect the circle at 2 points, and that is said to be secant to a circle, and this is called what? This is our secant to a circle. So children, what do you mean by secant? A line which intersect a circle at 2 distinct points is called secant to a circle. I hope this is very clear to you. If at all any line which is intersecting circle at 2 distant points, that is said to be secant to a circle. Now coming to case number 3. In this case, line L which is intersecting the circle at only one point. For suppose the point is P, and this line is said to be tangent to a circle. T-A-N-G-E-N-T. Tangent to a circle. Students, what do you mean by tangent? If a line which intersects a circle at only one point, that is said to be tangent to a circle. Okay, so I hope the topic is about tangents secant to a circle. So tangent in the sense, if a line touches the circle at only one point, that is said to be tangent to a circle, and if a line touches the circle at two distant points, that is said to be secant to a circle. Now see, this is our circle with center O, and this is the line L which intersecting the circle at point P. I mean this point P which is common to both the circle and as well as line, and this point is called as point of contact. Point of contact. The point which is common to both the circle as well as given line. That point is said to be point of contact. Right? Children, we know that distance between center to any point on a circle is called radius of the circle. Yes, radius of the circle. And this is, as we know that which is our tangent, and this radius OP is radius. Okay, if you consider this is a line AB, so AB is tangent, because a line which is intersecting the circle at only one point, that is said to be a tangent. Here line AB is called tangent. If you observe here, radius which is perpendicular to the tangent. See, you can see here the angle which is, how much is the angle which makes an angle? 90 degrees. So here you have to understand the theorem. If radius, that is called OP, which is perpendicular to the tangent AB. Radius is always perpendicular to the tangent at the point of contact. See, this is our point of contact. So OP is our radius, AB is our line, OP which is perpendicular to AB. Okay, for example, one more, you see, this is our circle with center O. For example, this is our line CD. This line which is intersecting the circle at only one point, let it be P. So what is OP, children? OP is our radius. Line CD which is intersecting the circle at only one point, it is said to be tangent. Here OP is our radius, CD is our tangent, and which makes an angle how much? 90 degrees. OP is perpendicular to CD. This is the symbol for perpendicular. Perpendicular in the sense 90 degrees. At where? At the point of contact. This is our point of contact. From theorem, what is the theorem? Radius is always perpendicular to the tangents at the point of contact. Okay, so we can write here also. For example, this is our tangent and this is our radius. Radius is perpendicular to the, this is our radius and this is our tangent. Radius is always perpendicular to the tangent. Right? So now coming to, this is our circle with center O, and this is our point P which is outside of the circle. Now my question is, how many tangents can be drawn to a circle with an external point? We can draw two tangents to a circle with an external point. See, if you observe, children, this is one tangent PA and this is another tangent PB. Okay, how many tangents we can draw? We can draw two tangents to a circle from an external point. So this P is an external point to a circle. You can see here OA is our radius and OB is our radius. Right? See, if we join O to 2P, what you will get, students, here? You will get a triangle. Which triangle? Right angle triangle. Right? So here PA is called tangent. PA is one tangent. And PB also one tangent. Why we called as PA and PB are tangents? Because PA is a line which is intersecting the circle at point A. PB is a line which is intersecting the circle at point B. So there are two tangents can be possible from an external point. We can draw two tangents to a circle from an external point. Okay, here OA is our radius, OB is also our radius. And also length of tangent drawn from external point to a circle are equal. I mean length of tangents, length of PA must be equal to length of PB. If you want, you check it. We have two triangles here. One is triangle OAP and the second triangle is OBP. Okay, by using similar triangle property, you can see as OA equal to OB, OA and OB, they are radius. OA and OB are radius, and you can see angle OAP is equal to angle OBP, each 90 degrees. And also OP equal to OP, that is common side, which is common side. So we can say that by RHS criteria, right angle hypotenuse side criteria, we can say that triangle OAP is congruent to triangle OBP. If two triangles are congruent, their corresponding sides are equal. What are the corresponding sides, children? That is AP is equal to BP. By CP, CT, by corresponding parts of corresponding triangles, I can say that AP equal to BP. Length of tangents drawn from external point to a circle are equal. For example, AP equal to 8 cm, the length of PP also 8 cm only. Okay, AP is 8 cm, then automatically PP will be also 8 cm only. For example, now the thing is how to find length of the tangent. Given radius of circle is, for example, given radius of circle is 3 cm, radius of the circle is 3 cm, given radius is equal to 3 cm, and from center to external point, for example, this is 10 cm, alright, consider 6 cm, radius OA is equal to 6 cm, from center to external point is 10 cm. Now the condition is how to find length of the tangent. What is given, children? Given radius is 6 cm, from center to external point whose distance is 10 cm. Now the thing is we need to find length of the tangent. Once if you observe here, this is our right angle triangle. OAP is a right angle triangle. So this is our right angle is at A, and this will be hypotenuse. The side which is opposite to right angle is called as hypotenuse. In triangle OAP, AP is our hypotenuse. By using Pythagoras theorem, what is Pythagoras theorem? Square of hypotenuse is equal to sum of the squares of the other two sides. What are the other two sides? One is OA and other one is AP, children. Right? So here OP is how many centimeter? 10 centimeter, 10 square. OA is 6 centimeter, 6 square plus AP square. So 10 square in the sense 100 is equal to 6 square value 36 plus AP square. Once if you transpose 36 towards left hand side, 100 minus 36 is equal to AP square. So 100 100 minus 36, that is equal to 64, is equal to AP square. Square, if you transpose, it will become square root. So square root of 64 is 8. So what is the length of AP? AP value will be 8 centimeter. So what is the length of tangent, children? Length of tangent is 8 centimeter. Okay, how to find length of tangents? Understood? So length of the tangent, we can say that L is equal to square root of d square. This is called distance, children. Center to point, and this is our radius, children. So the formula to find the length of the tangent is L is equal to square root of d square minus r square, children. This is a very important formula to find the length of the tangent. Let us use once. How to find the length of the tangent? Here tangent is AP, which is equal to square root of, what is the distance, children? From center to an external point, which is given 10 centimeter, 10 square minus, what is the radius, children? Radius is 6 centimeter, 6 square. So which is equal to square root of 10 square in the sense 100 minus 6 square in the sense 36. Square root of 100 minus 36, 64, which is equal to 8 centimeter. In this way, we can find the length of the tangents. The second theorem is what? Length of the tangent drawn from external point to a circle are equal. What is first theorem? Radius is always perpendicular to the tangent. These two theorems are important, and we have discussed in this chapter about tangents and length of the tangents from external point to a circle, and the tangent is perpendicular to the radius. So that is about tangents. Now coming to secants. What do you mean by secant, children? Coming to secant, as we know that this is a circle with center O, this is the line which is intersecting the circle at two distant points, and this is said to be secant to a circle. Okay, so children, what is AB? AB is called chord. What do you mean by chord, children? A line segment which intersect a line segment which joins any 2 points on a circle. A line segment which joins any 2 points on a circle is called chord of a circle. So here AB is called chord. So what is the longest chord of a circle, children? See, for example, this is CD. What is CD, children, here? CD is called diameter as well as chord, children. The longest chord of a circle is called diameter. So what do you mean by diameter? The line segment which joins any 2 points on a circle, and that must be passes through the center of the circle. Right? So whereas chord, there is no need of passing through the center of the circle, but diameter, it must be passes through the center of the circle. Here CD is diameter as well as it is also a chord, because a line segment that joins any 2 points in a circle, and the longest chord of a circle is called diameter. Diameter is the longest chord to a circle. Okay, for example, EF is also a chord, right? Now, so for example, this is our arc. What do you mean by arc? A part of a circle. AOB is an arc. A part of a circle. A part of a circle is known as arc. And what is this region, children? The region bounded by an arc and a chord, which is known as segment. Segment which is bounded by a chord and an arc. The region bounded by a chord and arc of a circle is known as segment to a circle, and this is called as minor segment, children. Now coming to this is our major arc. This is our major arc, and this region, if you observe this region, this is the region bounded by a chord and bigger arc. That is called as major segment. Which segment? Major segment. Children, are you understanding the difference between minor segment and major segment? The region bounded by minor arc and a chord is known as minor segment. The region bounded by major arc and chord is known as major segment. Right? So this is about segment. Now coming to sector. What do you mean by sector? This is our center, and OA is our radius, OB is our another radius, AB is called chord. Children, what is this region? This is our sector. This is our sector. I mean, what do you mean by sector? The region bounded by two radii. So this is our radius, this is our radius. The plural form of radius is radii. The region bounded by radii, and this is our arc. The region bounded by two radii, radii and arc is known as sector. This is our minor sector, children. Now coming to, this is our major arc, and these two are radius, and this is called as major sector. So how to find area of sector? We have the formula for finding area of sector. The formula to find area of sector is x degrees by 360 into pi r square. Okay, x degrees by 360 into pi r square. That is the formula to find the area of sector. Okay, this is about secants related. Tangents means if a line touches the circle at only one point, that is said to be tangent. If a line touches the circle at two distant points, that is said to be secant to a circle. And this is our concept which is behind sector and segment. Now the formula for finding area of sector is x by 360 degrees into pi r square. Okay, children, if you want to find anything, area of sector or area of segment, we can also find by using the formulas. Okay, children, I hope this concept is very crystal clear to you. If you like, please hit subscribe button, like it and share it. Thank you.